All right, today we're doing something a little different. We're not just looking at a finished product, we're going on a builder's journey. We're going to pop the hood on Hermes 4, a really powerful new open source AI, and see exactly how it was made, the roadblocks, the brilliant ideas, and the whole messy, fascinating process.
It all really kicks off with one of the biggest, most fundamental questions in AI right now. How do you actually teach a machine to reason? Not just to spit back facts it's memorized, but to actually think through a problem, step by step, connecting the dots. That's the core challenge that Hermes 4 was designed to take on.
Okay, so here's our game plan. First, we'll get properly introduced to the model itself. Then, we'll explore the data it was trained on and a really critical problem the builders had to solve. After that, we'll see how it stacks up against the competition, discover its unique personality, and then wrap up with why a project like this is so important.
So, first up, let's meet our subject. Hermes 4 isn't just a single model. You should think of it more like a new family of models, built from the ground up to really challenge what we think is possible with open source AI.
Now, the key phrase you need to know here is hybrid reasoning. What does that actually mean? Well, it means Hermes 4 is built to be a master of two trades. First, it's designed to do that deep, complex, multi-step thinking to crack really tough problems. But second, it's also a generalist that can just follow all kinds of everyday instructions you throw at it. It's both a thinker and a doer. So, to build an AI like this, you need data. And I mean a lot of data. But here's the thing. It can't be just any old data scraped from the web. You need the right kind of data. So let's see how the Hermes team basically built a custom library for their AI to learn from. And this chart right here, it tells you everything about their strategy. Out of 5 million examples total, a whopping 3.5 million were specifically created just to teach reasoning. And they made these examples intentionally much longer to give the AI enough room to really show its work and think through complex chains of logic. So that begs the question, right? Where on earth do you get millions of high-quality examples of thinking? The short answer is, you don't. They don't really exist in the wild, not at this scale. So the team had to get creative. They built their own solution, a synthetic data factory they called DataForge. And this is where the real magic is. DataForge is like this incredible assembly line for creating brand new problems. It grabs a piece of text, say a Wikipedia article, and then completely transforms it into something new, like a rap song. Then it makes up a new question based on that song, answers it, and even has another AI act as the judge to grade the quality. Only the best stuff makes it into the training set. And this process can get surprisingly creative, even a little weird. To generate a bunch of different coding problems, they had the AI adopt different personas. This quote you're seeing, this was generated from the AI pretending to be a poultry industry expert who's totally freaking out about their broken dashboard. It's this kind of realistic, messy, real-world scenario that makes the training data so powerful.
But you know, building cutting-edge AI is never a straight line. There's always a twist, and the team ran into a major, totally unexpected problem. They had taught the model to reason so well that, well, it just wouldn't stop.
And this number is just staggering. On one of their key tests, the model got stuck in its own head 60% of the time. 60! It would just keep thinking and generating more steps of its reasoning until it literally ran out of memory, never actually giving the final answer. It was like a brilliant mind trapped in a thought loop.
So how do you fix something like that? Well, this is the really elegant part. Instead of some massive, complicated do-over, they performed a kind of surgical strike. They launched a second, highly focused training stage that was designed to teach the model just one thing: the art of knowing when you're done thinking and it's time to give the answer. And you can see the results right here in their report. On the coding benchmark, the fix was a home run. The error rate dropped by nearly 80%, and get this, accuracy actually went up. On a math test, sure, there was a small dip in accuracy, but it came with a massive 65% reduction in that endless thinking error. You take that trade-off every single day. Okay, so the model is built, the biggest bug has been squashed. Now it's time for the main event, putting Hermes 4 in the ring to see how it actually stacks up against some of the toughest competition out there. First up, a tough math reasoning test. And as you can see, Hermes 4 is right there in the top tier. It's absolutely neck and neck with the other state-of-the-art models. This proves its core reasoning engine is seriously competitive.
Next, let's look at coding. Now, it's not at the very top of the leaderboard here, but it's putting up a really solid score. It's holding its own in what is a very difficult, very specialized field, which just goes to show how versatile this model is.
Okay, now this chart is where things get really fascinating. This isn't measuring right or wrong answers. This measures behavior, specifically how often a model just refuses to answer a prompt. And on this test, a higher score is better. And look at Hermes 4. It's way, way up there, making it significantly less likely to refuse a prompt compared to giants like GPT-4o and Llama 3.1. And that tells us something really important about its personality.
And that personality is exactly what we're digging into next. Because, benchmarks and numbers tell you what a model can do, but they don't really tell you what it's like to talk to. So, what's the ghost in this machine?
To really get Hermes, we first have to talk about a common trait in a lot of other AIs, something the researchers call policy rigidity. You've probably run into this. It's when an AI gets so hung up on its safety rules that it completely misses the point. You ask it to help you write a scene for a story with a villain, and it gives you a lecture about why villains are bad. It's frustrating.
Hermes 4, on the other hand, shows what they call behavioral plasticity. It's just more aware of the context. It seems to get when a prompt is just for fun or for a creative project, and it plays along. It'll adopt a persona and actually stay in character without constantly breaking the fourth wall to give you a disclaimer. And for a perfect, concrete example of this, the researchers asked it to write a poem about French fries, but in the style of H.P. Lovecraft. And this is just a snippet of what it wrote. I mean, listen to that. It's not just talking about fries. It's capturing the entire creepy cosmic horror vibe of Lovecraft. This is an incredible display of its creative flexibility.
So let's zoom out. We've gone deep on how this one model was built, tested, and fine-tuned. But what are the bigger lessons here? Why does this whole journey with Hermes 4 really matter for the future of AI?
It really boils down to a few key things. First, data is everything, and custom-built, high-quality data is the new name of the game. Second, training smart is just as important as training hard. Those clever targeted fixes can solve enormous problems. Third, we have to look beyond just the benchmark scores to really understand what these systems are like. And finally, and this is maybe the most important point of all, because Hermes 4 is open source, this entire process, the data, the fixes, the results, it's all out there for the whole community to learn from and to build on.
And all of that leaves us with one last big question to chew on. We just saw an AI write a genuinely evocative poem about French fries. So if a machine can flawlessly adopt any style, any voice, any persona, what does that mean for our human ideas of creativity and authenticity? Where do we draw the line? That's something for all of us to think about. Thanks for joining me.